Okay, we're going to move on into Chapter 5. This is the next session in our Cloud Essentials Plus study. And in Chapter 5, we're going to learn about the management and technical operations. So in here, we're going to have several sections. One of them is the first one is explain aspects of operating within the cloud. Then we'll move on to explain DevOps in the cloud environments. And then third, we'll do the financial planning of cloud resources. All right, if you haven't yet, take a chance to read the introduction on page 164. And then hit pause and then come back when you're done. Okay, so then now you've learned a little bit in that introduction. It talks about thick and thin clients. So we really have moved into an area where we're no longer doing things with thick clients. I mean, we still are, but you don't have to. So if you think back in our history, before our internet and before our networking got really, really fast, we might have a mainframe and we'd have dumb terminals hooked up to them. And then if anything happened to the connection, it was okay because it was actually running on the mainframe. Your terminal just made it look like it was happening in front of you. And then we moved into mid-range systems. And then there was a period of time where our computers were really, really fast. And so we started writing software to take advantage of how fast our machines are. So if you think of things like Microsoft Office and, of course, games and other things, we would have this software that took up lots and lots of space and ran mainly on our laptops or our desktops. And then when the internet started getting better, we started writing software differently because it was better to have a bulk of the processing running on your mid-range server or your server that's out on the internet, and have your localized machine a little bit less powerful. And there was less of a need to have things running on your desktop. Now, the funny thing about that is, of course, our desktops are getting bigger and better and nicer and faster, but we can still use that, and it's good. But even if you look at something like Microsoft Office, if I'm running that on my computer, it works great. I could be on an airplane, not have internet connection. It works great. I can continue to use these products. But then if I get somewhere and I want to use Office 365, I can use the same computer or a different computer and sign in, and the application is running out there in the cloud, and it works almost as good as it does as it's running on the machine in front of you. So this gives us a lot of power. And then, other benefits from this, we don't have to run the software. We don't have to worry about, having that software pushed out to the local machines because we can have it running just in one or two places out in our cloud environment. So lots of good reasons that we want to do that. So in this introduction, when it talks about thick and thin clients, that's what it's talking about. It's saying thick clients, meaning the client, the machine that you're on, the machine in front of you is thick, it's good, it's powerful. Or now we can move to a thin client where you think of, a less powerful machine. Like, you could even have a Google Chromebook that has very little processing, very little hard drive, and you can run that. And that's a very thin machine, but they're very useful because you can sign in and do most of your work out there, in the cloud. So some of the things that we would want to discuss here when we're talking about our management tools for being in the cloud, we will refer to our management console. This is where we sign in and work with our cloud resource. Then we also have our command line interface. Same thing, but it's less of a point and click. It's more of an automated type of thing. It's a command line interface where we can run scripts and do things to our cloud environment, and lots of different reasons, and we'll get into why we would want to do that. And then we also have our software development kits, where it's the same type of thing as command line, but we're using a programming language like Java, .NET, some of these packages that are out here that interface with our cloud. So the first section in Chapter 5 is the explain the aspects of operating within the cloud. So we're talking about explaining the aspects of operating within the cloud. One of the things that we want to refer to are things like data management, availability, disposable resources, monitoring and visibility, and optimization. So the cloud opens up this new world. We still need all the historical concepts and terminology of how we're adding, but now we're adding this layer that is the cloud. So yes, we're sort of, and I put sort of in quotes, just moving our on-prem data centers into commercial clouds. But there's more. So we'll be taking advantage of the global infrastructure of our CSPs. So again, the different areas that we're going to refer to in this section: data management, availability, disposable resources, monitoring, visibility, and optimization. So the first thing we want to take a look at here is our data management. So we've been doing data management in IT for many, many, many years, for sure over 50, longer than that. Maybe the general public hasn't, but our government and high-end companies have always been taking advantage of information technology and the technology that's out there to help. And of course, that flows into our data management. But now we're talking about data management within the cloud. So we're going to go deeper into showing what the global infrastructure is of the cloud here in the next slide or two. But right now, focusing on data management, we think about what are the needs for us to ensure that our data is protected. So we've talked about this a couple times, but think about in your own life. What's the most valuable things you own? Our parents probably would have had things that they would have said were the most valuable thing in their home. It might have been their photos, books of photos, and then things that are inside their house. But for us nowadays, our most valuable asset is our data. I think most of us would agree. If you got into our homes and you took something, it would be a shame. We wouldn't like it. But if you took the TV off our wall, we'll replace the TV. If you take something, unless it's a family heirloom, you take something out of our house, it's okay. If we know what it is, we can go find another one. But if you think about losing your pictures, losing photos of your kids, of your family, that is the most valuable thing to us. And that's the thing that we spend the most time thinking about and deciding how we're going to protect that. So even at a very, very personal level, and of course, businesses have the same thing. They have data that is important to them. So when we're thinking about our data management, our most valuable asset, we think about the replication. Where is the data available? We want to make sure it's not just in one place, it's in multiple places in case something happens to that one location. And then we also locality, the location or the proximity of the data. What we're talking about here is saying that if I'm accessing that data, I want it in several different places because I don't want the people that are on the East Coast accessing the data out of the West Coast and vice versa. You want to put the data close to the users. And then the last thing in this data management discussion is the backup for disaster recovery. Where are we going to keep this data? How much of it are we going to keep? How long are we going to keep these backups? And we want to practice up whenever we're doing disaster recovery exercises. We want to make sure that we're not just assuming everything's okay. We want to practice up and make sure that we can pull from a backup and bring it back in. Okay, so then now when we're looking through those sections, we're going to do a little deep dive on each of them. Replication. So this is your data availability. So we're going to watch a couple of videos here. We're going to watch one from AWS and one from Azure. I chose very short videos on purpose. Just know that, we're just barely scratching the surface here. You can get in here and learn a little bit more. But we've talked a bit about availability zones. So as we're discussing this, remember that you have geographic regions around the world. These are called regions. And inside the regions, you have multiple data centers that are called availability zones. So let's go out here to the video and let's watch and let AWS tell us about what they consider an availability zone and Microsoft Azure, which is very, very close. But again, two different companies. They weren't watching each other. They were doing their own thing. So there's a few little nuances here.
In an ever-changing and uncertain world, AWS has stayed consistent by building resilient, global infrastructure designed to meet your evolving needs. AWS's infrastructure and network is architected to meet the highest levels of security, compliance, and data protection. From day one, AWS knew the importance of supporting high transaction, low latency applications that can replicate data between geographically dispersed data centers. That's why each AWS region is built with multiple availability zones that are separated from one another by a meaningful distance, and each have their own redundant power, networking, and connectivity. AWS's expanding global infrastructure portfolio is here to meet your needs. Choose the infrastructure type you need to build highly available applications and get performance that exceeds expectations. Pick any region around the globe for your most demanding workloads. You can use CloudFront to quickly deliver your content, AWS local zones for low latency applications, AWS Wavelength to deliver powerful 5G applications on demand, and bring the cloud to your data center with AWS Outposts. The AWS Cloud is built for your needs today, tomorrow, and the future.
Everyone, in this video, I want to just go through some of the basics and use guidelines for availability zones. I see a lot of questions and comments around them that make me think a lot of people are not really understanding the key goal of availability zones. So let's sort all that out. As usual, if this is useful, a like, subscribe, comment, and share is appreciated, and hit that bell icon. So we often talk about regions, and regions all throughout the world. There are maps where we can see all of the different regions. And what is a region? So we really can think about, well, the whole point of a region is it's multiple, typically, facilities within this kind of 2 millisecond latency envelope. So there could be multiple physical buildings that actually provide the various capacity that I'm using when I deploy things into that region. And then within these data centers, there's various clusters that are made up of multiple racks. You can think of each rack as a fault domain, has its own kind of power, networking switches. And through this, it provides those compute services, the storage services, etc. Now, when I think about resiliency within a region, well, at minimum, I want to make sure I have at least 2 instances of any service. And at minimum, I want them on different racks, different fault domains. And that was really the point of availability sets. But what about if there was a data center level issue? And so what was then enabled to us was availability zones. So in many regions today, we have this option of availability zones. And we can actually go and see that. So if I actually jump over to this web page, it will actually show us. Let's go and look. Click this link. And we can see these are all of the regions with availability zones. So there are a lot of them. Right now, I can see in the Americas, in Europe, Africa, Asia Pacific. All of these support availability zones. Okay, great. What's an availability zone really then? So if I think about, we have these unique physical environments, the whole point of an availability zone is isolation. And it's really isolation around power, cooling, and the network. So any kind of localized failure of those things, they should be different for each of the availability zones. If there was some localized power or cooling or network issue, it would impact one availability zone, but not all of them. Now, obviously, if there was some big regional level problem like a flood, a natural disaster, hey, it might impact all of them. Regions are picked, the locations are picked within the region that have protection from kind of natural disasters, not on floodplains, etc., but things still happen. The whole point of an availability zone is its isolation from power, cooling, and networking of the other availability zones.
All right, I'm going to go ahead and stop there. You can watch that video anytime you want, but he said the core of what I was wanting you to get out of this. I wanted an AWS example and an Azure example of what an availability zone is. So both of them point out that if there's a failure in one data center, and again, an availability zone is like a data center. It can be in multiple different buildings, or it can all be in one building, but you're going to have multiple availability zones within a region. And they're going to try not to share electrical grids, floodplains. They're trying to protect themselves as much as they can within the geographic location and within the region, but they still need the latency. So he was talking about the 2-second item. So what we've determined is that if we take two machines and we stick them right next to each other and we run fiber between them, that is as fast can be. I mean, it is fast as the speed of light, and we don't notice any latency at all with these machines that are right next to each other. Now let's pick one of these machines up and let's take it as far away as we possibly can. And how long is it until that speed of light catches up and we will notice a tad bit of latency? It's somewhere in the neighborhood between 20 and 30 miles. So if you think about the region that you live in, and think about wherever you are, think if I was going to go 30 miles from here and set up a data center, what would make the most sense? So if a lot of you in this class are in Kansas City, you would probably want to pick somewhere on the opposite side of the river. You would definitely want to make sure that you were in different areas where the electrical grid was not the same. So, we can all think of our own city and think about where we would want to put our availability zones to keep them far enough apart that we're not going to run into any natural disasters that occur at the same time. And then also, but you want them close enough together that there's zero latency. And in one way you can do this, next time we get a big snowstorm and electrical lines go down, and you can look and see what areas of town lose electricity. It's usually, I shouldn't even say this because now next time we'll have a whole Kansas City outage. But, usually if you look around the area, there's never more than just a couple at the same time that are having issues. All right. And then two types of data replication, synchronous and asynchronous. So synchronous data is written on multiple locations at one time. Asynchronous is data written at a specific time and has an RPO. The next thing we want to take a look at here is our locality. So this is the location or proximity. It's the speed of the internet is still limited by the speed of light. Locality refers to the location where your data is in the CSP's infrastructure. So again, that speed of light, that's the thing that we're always talking about is fiber, speed of light. I would never say never, but I don't think we're ever going to get faster than fiber and speed of light. That seems to be a pretty good standard. But of course, you never know. We've overcome other obstacles and we've gotten faster and faster and faster. But so our locality, this means where is our data? We want to have it somewhere close to our users. And so there are several things that come up in the conversation of locality. We'll talk more about edge locations later I don't remember if it's in this chapter or the next chapter, but we do refer to our edge locations and how we set things up so that we have our source data, but it's pushing that data out to put the data that people need to read right next to the customers. So we'll discuss that more. All right. And then the last thing in this data management conversation is our backup. In the event of a disaster recovery, or not even just a disaster, but we're taking backups every day. We hope we don't need to go back to them, but if we do, we want to make sure that it's an easy thing to be able to roll back to a backup. And so some conversations that we have around this is how often do we back up? And whenever we have that backup, how long do we keep a backup? Like, is a backup that's 6 months old, will that do us any good at all? Probably not. So we need to have those conversations around every type of data to say, okay, this system, it's backed up this often, and we save this many days worth of backups, and eventually we start rolling them off so that we can save money. So, some other concepts around the idea of backup: plan for failure, malicious failure, or natural disaster. We want to think about our databases, want to think about our hardware and our network. So then we take these snapshots and rolling back and returning a VM to the state of the snapshot, creating a new VM from the snapshot, an effective copy of the original server, and then copying the snapshot to object storage to be used for recovery at a later date. So lots of different conversations, and they're all conversations, and they're all things that we want to consider. And this still goes by the same rule. There's not a silver bullet. There's not just one way to do it. We want to look at each system. We want to look at the data that's in those systems, and determine a plan that best meets that. Okay, and then a little bit more on availability and our availability zones. So availability is one of the largest benefits of using the cloud. CSPs over the scale that would be difficult and costly for anyone to implement on their own. So think about this. If you're running a company, and even if you're a really large company, to get more than 2 or 3 data centers in the country gets to be an extremely costly event. So let's say that you have things running in Dallas, and then you also have a data center in Kansas City. And then you think, okay, we're all in the middle. I better get a data center out in California somewhere, or Oregon, somewhere in that part of the world. And then I probably better go ahead and think about getting something in the Florida area or the New York area, somewhere out there on that East Coast. And next thing you know, you have 4 or 5 different data centers. They may work for you, but think about how expensive that is. We've talked about how it's not just the running of the data center. You also have the security of the data center, the cooling, all the things that go part of that, all the people that work inside that data center. So it gets to be extremely costly. And then also think about something that we haven't really discussed yet. Let's say that everything we have is running, it's going really good, and then we strike some deal and we want to move to Europe to pick up our operations and start anew. If you're doing that yourself, you have to go out there. You have to have somebody go there, learn the local laws, talk to the people there, see what you can do. You have to purchase a building, extremely costly, very time consuming. But if you think about how we do this in the cloud, it's just a button click away. So way, way cheaper for us to utilize somebody like Microsoft or Amazon or Google to go out there and take advantage of the zones, the availability zones, and the regions that they already have. And then the whole concept of geo-redundancy gets way easier whenever we're talking about living in a cloud world. So we talked about the zones, we've talked about the regions. So regions are geographic locations, and they're chosen to be hundreds of miles apart, or in some cases, maybe even 1,000 miles apart. But we want them as far apart as we can possibly be, but we still want our connections there to make sure that we can move things quickly between them. So if you look at the regions, the geographic locations for AWS, they have 1, 2, 3, 4, 5 within the US. And Azure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 within the US. More doesn't necessarily mean better, but you definitely want to be able to have these geographic locations separated enough that you know that if a bad event happens in one area, that same event is not going to impact the other. So we've talked about zones and regions, and then geo-redundancy. So this is next level up, offers cross-region availability. Services are replicated between regions to offer greater availability. Unfortunately, physics and the speed of light rear their ugly head and place limits on how quickly cloud services are in sync. But when we were talking about our databases, here is a Here's a view of, ignore the blue dots, but just look at the regions, the orange dots. So these are the AWS regions around the world. So if we are backing up, let's say we're running in this region right here, and then we're backing up for disaster recovery purposes all the way over here, we figure out quick, better ways to do that. We don't necessarily every transaction have it go over, but we figure out some plan that makes sure that our databases are being backed up as quickly as possible in that. So we're backing up instantly within our availability zones, but then within our regions, we also have a plan for our important data to be backed up in case there is some kind of natural event, natural disaster or bad event. So now I've told you to just look at the orange. Now let's add in our blue and this little purple. So the purple is multiple edge locations and the blue is an edge location. So again, think of an edge location, which I know we have in one of the chapters, we go deeper into this. So this is just a high level reminder of this conversation, and we'll talk in more detail about this. But in here, what we have is we have a source of the data, and that source is feeding out to all of these edge locations so that we can keep the data right next to our consumers. So let's say that, let's take Netflix as a good example. Let's say that Netflix home is right here, and I don't know where it is. I'm just making one up. I'd be willing to bet it's out in California somewhere, but I do not know that. But let's just say that Netflix home is right here. So they bring new movies in, and they want to make sure that those movies are available to their users. So they send this out to all of their edge locations. So then now you, the consumer, are about to go watch a movie. You click on a button. You're not going all the way back over here to pull that movie. You're going directly to the closest data center to your home. So this is why we have these edge locations there for content delivery network. Now there's also some other functionality that the book doesn't go into, but I always feel it's important to bring out. If companies want to take advantage of how to use these edge locations, they can also make it. So let's say that I'm right here and I am uploading files. And so I upload the file to the closest server to me. So for me to click and drag those files, boom, it just takes a second or two and they are there. Then that edge location can actually propagate those same files and put them out in all of the other edge locations. I work with some companies that do this, and it really is remarkable when you see it work. You're thinking, I cannot believe that I'm able to throw this file out here and it takes like 3 seconds. If I'm moving it from within my own network and I'm moving it across a couple of states, it takes 25 minutes. But I click and I drag it and I put it here and it takes 2 or 3 seconds. If you've ever noticed something like that, there's some kind of background, like this content delivery network that's built to make that happen for you. So again, just to tie all of this conversation together, we have our zones, which are geographic locations. We have regions, which are geographic locations. Then we have zones that are data centers working within that geographical location. And then we have our geo redundancy so that we can not only have things backed up 30 miles away, we can have things backed up thousands and thousands of miles away to ensure that we're in good shape. Okay, so the next thing we're going to look at here is disposable resources. So recall going to the cloud, we said no upfront cost. So we can build and duplicate environments in minutes. This allows bootstrapping, golden image, and hybrid. So we'll go more into those definitions, but first thing, disposable resources. We've talked about how we can replicate a system. So if I have 5 users on, I'm running one server and then 10 people log in, and I know I need 2 servers, and then 10 more people log in, so then I know I need 3 servers. And then towards the end of the day, as people fall off, those start getting, we can go from 3 servers to 2 servers to 1 server. So those servers that were out there are disposable. It's not like we just turned them on. We actually created the instance of it, and then whenever we are done with it, we shut it down and it ceases to exist. We can create another one anytime, but these are referred to as disposable resources. So we talked about how it allowed bootstrapping, gold image, and hybrid. So let's go through the definition of these. Bootstrapping, taking an already tested and verified VM image and applying the post-deployment process after the initial start. So again, bootstrapping, we've talked about hardening of a server. It's the same thing. It's taking an already tested image. Then when you deploy it, it quickly goes out and sees what else does it need to do to be the best that it can be. And so that takes seconds, and then boom, we're up and running. Then we have our golden image. This is taking an already tested and verified VM image and customizing and deploying. Then hybrid, a cross between bootstrapping and golden image. So you perform any complex advanced deployments through the golden image, but anything that is relatively easy to script, you put in the post-deployment launch. All right, the next thing we want to talk about is monitoring and visibility. So compare this to what we've traditionally done in our on-prem data centers. Multiple teams at multiple locations, multiple response organizations. So I've worked in organizations that had teams running here in Kansas City, had other teams running in Denver, Colorado, and then teams running down in Louisiana. Every one of those buildings had people that were involved in making sure it was secured, having the building opened up. Those teams also usually had people that were working in there in different areas, including response organizations like help desk. Also, if you have a data center running, you need to have people that are near that building prepared for any type of activity that you need to bring them in. So again, it creates a life. It creates it creates an organization of people to run that building. Now think about what's available in the cloud. We have alerts and logging all in one place. We have one person, doesn't matter where they are, they're in the management console. They create all of the rule sets that run for everything that's in this region to the next region to the next region. It just propagates out. So we don't have to have people running in every one of those locations. We can have somebody running our infrastructure layer in anywhere in the world that we want them to be. And then alerts. We have billing and storage and compute and networking. They're all threshold based. So in other words, when a resource A reaches a threshold of X, an alert is generated. Remember, we start out, we just have alerts. Say, if we have this type of issue, I want you to send me an email. And then when I get that email, I'll sign in and fix it. But then we decide, I'm tired of doing that. What I'm going to do is let's have that alert go to the tool and automatically self-heal. Let's have it spin up more resources if we need. Let's have it all do this automatically. And so, over time, you get this system that can heal itself anytime, and it just needs minimal oversight. And then logging, recording of events and actions that have occurred against an asset. Logging is critical for any organization that utilizes technology. So working in IT, you have to handle situations where someone has asked what happened after something goes sideways. Logs are going to be the primary source of information on past events. So let's say that you have the system running and then something started messing up at a certain time. So you go back and you look at the logs and you see what occurred at those times. You might find that machines went down. You might find that some certain user signed in and did something. It's all going to be there in the logs. So that's how we go back and determine what changed in the environment to cause this issue. All right, now we're talking about optimization. Optimization, cloud offers agility that has not been realized on-prem. So auto scaling, this is that concept of what we've been talking about, horizontal and vertical. So, our vertical means that we're adding resources to an existing server in order to make it perform better. So let's say that, we determine that we need more memory. So we add memory to the server, but then also scaling out or horizontal. This is the example we talk about where we have a certain number of users on, and then we know that when we go up another 10 users, we have to add resources. So we add another server or we add another container, and then we can grow as much as we need. And then when we're done with it, we can shrink it back. So this has to do with the right sizing. So keep in mind, there's always two things we're playing with: performance and cost. We want to keep our costs low, but we want performance good enough to run our workloads. So that's why we don't just add servers and leave them running. Remember, you're paying for the server while it's up. So it behooves you to create resources as you need them and then remove them when they're no longer needed. The next section we're going to look at here is explaining what DevOps in cloud environments is. So DevOps, if you want to read more on page 180, DevOps is the combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. So evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. The speed enables organizations to better serve their customers and compete more effectively in the marketplace. So here's something I just grabbed off of a blog, and I put the link here to the blog if you want to take a look at it. But it describes the DevOps pipeline. In short, the DevOps pipeline is development, build, test, release. But in essence, what we're really trying to do is, in traditional software development, we would create, we'd pull out our code, we would update it, we would check it back in, then we would build a release, and then we would deploy that release, we would test it, go back, and change everything. After we went through the test, we'd have to go back in and update things and then put it back in test. And whenever it was finally accepted in test, then we'd move it to production. So we used to be able to do this at best once a month, in some cases once a quarter. But then the whole agile development process came around. And so not only does agile development impact the way that we do traditional software, but it also created this advent of this DevOps mindset and the way that we do things. So if you look here, let's just start here at our code. So we use whatever products we need to check our code out, do coding, and then put it in. Then we use build products to create the build. Then we test it, and then it's released, and then it's deployed. And when it's deployed, we utilize things like Dockers or our cloud service providers. And then we operate. This is where people are actually using this, the code out there. And we use different tools for this: Chef, Kubernetes, Puppet, and then monitor. And so monitoring has a whole slew of products that we would use. And at the same time, we're doing a plan. It's like, what are we going to do next? So with this, we start doing smaller chunks of code. So we're not running into this test plan and having to roll back, test and roll back. We're doing little bitty pieces of code. We're trying to do constant improvements. So we code, we build, test, release, deploy, operate, monitor, plan for the next one. The planning phase is always going on. We have a stacked up backlog of things that we are going to try to get done. And so we just keep going through this process. And if we get this good enough, this process could be as short as 2 weeks. So we are continuously delivering software, and we're continuously driving improvements for our business. And so it's kind of, for some people who are just getting involved in IT, this is all you've ever seen. For people like me that have been doing this for 25 years, this is something that we had to work into. And the first time we might have been presented with something like this, we might have thought it was crazy and we didn't think it was going to work. But over time, you see that it does work, and it works better. And you make your smaller versions of your code changes, and it just improves everything. There are lots and lots of tools out there, and depending on who you're talking to, they'll talk about which ones are the best. So in this slide, you'll see that the slide previously had a list of tools that we might use, and then here are the lists that your book mentions. So it says source tools: GitHub, Apache Subversion, build tools: Jenkins, Microsoft Visual Studio, testing tools: Selenium, Pester, Vagrant, and release tools: Chef and Puppet. Again, there are lots and lots of tools out there. The ones that are on this slide, very, very good, very well known, a good group of tools, and of course the ones on this side as well. And you'll learn as you get in. Every organization has a reason why they went with a certain tool set, and again, they all work pretty much the same. Next thing we want to talk about here is our provisioning. So we're going to need resources to work along in this pipeline. So we're going to need to create these in the cloud or provision. So to build what we have learned in previous section, we should build immutable and disposable resources. So remember, it's key, these cloud resources, for us to truly take advantage of cloud, they do need to be disposable. Now, there are people that come in and they essentially reproduce their data center, especially with really large servers. And if they're doing that for performance reasons and need to keep it going, that's still a legitimate use of the cloud, and it works very well. But whenever we're really, truly taking advantage of our cloud resources, we consider everything that we throw out there as disposable. So one thing that comes into conversation is infrastructure as code, or IAC. You'll see it with the big I, little a, big C. Infrastructure as code. So there's lots of good use cases for building things in infrastructure as code. As a matter of fact, I would say that there's very few legitimate reasons why you should not consider building all of your resources with infrastructure as code. So if you're reading through your book, you're going to learn about the imperative and declarative approach. You're going to learn more about the tools and the CSPs like AWS CloudFormation. Azure has Azure Resource Managers. And then there are these other tools that are outside of the CSPs called Terraform, Chef, Puppet. And then we have our templates with the type, the image ID, block device mappings, and then stack deployments for to automatically create things like WordPress, multi-site, Microsoft Windows Server, Active Directory, Magento. So when I talk about the different use cases that you might want to use infrastructure as code, so let's say we're working on a really big environment and we've built it out and we've used infrastructure as code all along the way. And, this environment has some huge servers, some small servers, lots of networking pieces. And if you use the infrastructure as code, it's kind of like a listing of everything that's in your environment and how you would go about building it. So it's essentially, I'm going to simplify this and say it's a text file that you could pick up and deploy somewhere else. But let's say that you're working along and you have this big application, and then all of a sudden you run out of funding. And people say, we have to shut this down immediately. We can't even keep the account. There's legal reasons we can't. If you don't have infrastructure as code and you shut it down, you delete the account, it's gone. It's gone forever. But if you have infrastructure as code, you could back that out. You could back it up into on your computer in a thumb drive. It's a really small file. And then you can set it aside. And let's say we go about 3 or 4 years down the road and they say, hey, that program that we picked up that time, we need to get that going again. You can pull that out, deploy it. You can create a new account, deploy it, and you are back up and running in minutes. Think of another use case for this. Let's say that you built out an environment that runs some software that you've been selling. So you're out and you're selling, you're on a customer site, and you're showing them what this thing can do. And they say, we'd really like to try this application. So you can sit there and say, okay, well, let me spin you up an account. So you go out to the CSP, you spin up the account, you deploy the infrastructure as code. It's up and running. You install your software, and in a few minutes, you can hand the keys over to the customer and say, here you go. Here's your environment. If you use it and want to keep using it, you'll start paying me. If you want to use it to try it out and then play around with it and then delete it, we can delete it for you in 30 days. And it'll be gone, and no harm, no foul. You just pay for what you've used thus far. So again, lots of different reasons why you'd want to use infrastructure as code. And if you do it correctly within your environment, you can actually, when you have people in that are pointing and clicking and making changes, you can have that roll back in and fall into your infrastructure as code. So the main thing is that you know what it is. And when you're working with your developers and DevOps resources, you demand that they do this, and then you check and make sure that they are. And again, we could go on and on. I know people that do this essentially for a living. They work with Terraform, Puppet, and what they're doing is creating an environment that people are using today. And then beyond that, they also are creating the infrastructure as code in case the customer needs to pick it up and move it somewhere else. Next thing we want to discuss here is continuous integration, continuous delivery, or the CI/CD pipeline. This has been a really, really popular conversation and pretty much expected with most software deployments now. So if you're selling software to other companies, you're playing a consultant role, you're going to want to include a slide in your deck that has to do with the CI/CD, continuous integration, continuous delivery. So it's kind of been synonymous with DevOps. So in short, where an application updates and changes are consistently being released. So we build on our previous topics, delivery, and in the concept of the CI/CD. So you remember the big figure 8 diagram that I had up where we go through the different stages. This is all part of that. It's continuous improvement, continuous integration, continuous delivery. Taking small things that the business need, and you try to make them small enough that you're not deploying anything that's going to hurt any other area of your code. So you're continuously improving your customers' needs in a continuous manner. So this goes along with our going from dev test to UAT to prod. I showed you it was a little more complex than that, but one of the keys to this is automation. So you put your code out there, you take a little piece of code, you update it, you put it out there, boom, it flows through the process, and you just keep on adding improvements. There's always opportunities to roll back when needed, but the best way to do this is to write your code in a way that you don't have to roll back. But that's a different conversation. Next thing that we want to discuss here are our different types of provisioning and different environments that we can work with. For some of you, this is brand new vocabulary. For some of you, you've been dealing with this for years. But in short, we want to make sure that we're all talking the same language. So when we talk sandboxing, this is a separate environment. It's a beta or test. It's just like it says. It's like it's a sandbox out here. It's not ever going to be used for production. It's a place for you to go out there, get to know a new application, play around, completely disposable. Then we have our load testing. It's one of the hardest types of testing to execute in the real world. What is the proper load to test? How do you simulate the load without real users? What other load testing besides user loads do we need to test, like database loads? But load testing is a way that we replicate as many users as we want, or as many processes. So a lot of times, we'll throw it out there and we'll say, what does 5,000 users look like when they're on the system and using it? What does 10,000? What does 50,000 users look like? Now, we've talked about some cloud principles, and I will tell you that whenever you're doing load testing, you really have to be careful that you don't leave your automation in place, because if you do, you'll just keep spending up resources and you won't actually be able to get a fair representation of what a load does to the system, because it's self-healing. So what you'll end up doing is spending a lot of money, but not actually testing your system, which is a good thing, because in cloud, a lot of times we can get away from having to do this load testing if we write it in a way and we know that we're keeping it up and going. But I've been a part of applications that had penetration tests and load testing that they finally just had to remove. And they said, we can't do this anymore because all it's going to do is keep healing. We're just going to spend a lot of money. We can't actually test the system. Another form of testing that you need to know the definition for is regression testing. So this validates that new features don't impact production. And so we've all been a part of software. I have. I assume some of you have seen this. But you put some code out there and it fixes one thing, but then it breaks another thing. So you have to have a series of tests that you run to ensure that your system is really good in all aspects. So most systems have a series of tests that they run for every deployment, and hopefully it's automated so that when they put new code out there, you can do a regression test and make sure that none of the new functionality impacts anything else you already have running out there in production. A few more things that we need to add to our vocabulary and be able to speak to: orchestration, the glue that or the coordination between automation tasks. Orchestration will free up resources, both digital and human, so they can perform other tasks. Orchestration strives to make automation efficient and manageable. Managed automation is great and necessary for DevOps, but unmanaged automation will lead to issues of who, what, and when. So again, this has to do a little bit with our change management and our logging. You just want to make sure that you can always tell what went on in the environment. And then the next thing, automation. Automation. Everything we do, we want to include automation. Not only does it make it faster and cheaper, but it also removes human error. So that's one fear that we always have is if we are doing things in a manual way, do we do it 100% correct? So the more automation you can have in your systems to ensure that there's less human interaction, the better. The last two things we'll talk about when we're talking about our provisioning section, upgrades and patching. So in case you don't know this, all operating systems usually get monthly patches. So you have your Windows and Unix. And so you always have a plan for when you're going to patch your systems. Most companies have kind of fallen in the cloud world, especially have fallen to a patch all non-prod the second week of the month and all production the last week of the month. That gives you 2 weeks of testing in there and everybody knows when it's being patched. That way they can go in, do all of their testing to ensure that the patches didn't mess anything up, and then we roll them on into production. And then the last one is API integration. The last section we'll go over in our Chapter 5, Management and Technical Operations, is our financial planning of cloud resources. So how can we ensure total cost of ownership is cheaper when we move to the cloud? We need to consider some of the following questions. So before we go through there, I want to make sure you understand total cost of ownership. Anytime you're talking total cost of ownership, you're talking about total cost. So this is a good comparison to what we ran on-prem versus what we run in the cloud. Now, so this is where some interesting conversations come out because people talk total cost of ownership. They say, well, I can run a server in my own data center for such and such amount. Well, does that include the people that are there? Does it include the electricity to the building? Does it include the building itself? Total cost of ownership. You have to take into account everything. If you pay somebody to mow the yard around the data center, that is part of the cost. So remember, total cost of ownership is a conversation that when it comes up, you have to explain what total cost of ownership actually means. So when we're looking at total cost of ownership, we have to consider some of these things, or we have to consider all of these things plus, even more. This cloud service provider offers several different types of storage. What are the use cases for the different types of storage? Do we need to use commercial software that needs to be licensed? We have a department that wants to move everything to the cloud. How can we track expenses and pass along the charges to that specific department? So there are three main categories when we're talking about the finances. We're talking storage, network, and compute. So remember, I always talk about the big three: storage, network, or actually I usually say compute, storage, network, and then services. Those services can include database services, lots and lots of different types of services. But in our financial planning, we focus mainly on the three that have to do with replacing our data center. All right, so then the three types of storage options that we have are object. So object level storage is storage for the internet, or object level storage. It's AWS's flagship product in 2006, their simple storage service. We can take a look at the pricing of this, but essentially what I really want you to gain out of this: object storage. Object is anything that you can save. So it could be a Word doc, it could be an Excel file, it could be a music file, it could be a video file. Any kind of file out there is an object. So if you can use object level storage, it's one of the coolest features of moving to the cloud. So I'm going to bring this over really quick. We're just going to quickly look at the pricing of storage. So again, this is simple storage service. Amazon put this out. It's one of the first things to hit the public about the cloud. So you can see here for the first 50 terabytes, it's a little bit more than 2 cents per gigabyte per month. So think about that. A gigabyte, you probably everything that you've saved, all the pictures you saved and everything are in the gigabyte range. Maybe let's say like 200 gigabyte would probably cover most of what you're storing out there in the internet if you're storing everything you own. So we're talking 23 or 0.23 cents. I'm sorry, not 0.23, 2 cents, 2.3 pennies out there. And then as you use more, it gets a little bit cheaper. Then we also have our intelligent tiering, which I'm not going to go into detail on that right now. But there's even ways to get it down to where it's less than 2 cents. Like if you say, I can replicate this, so I just want to put this out there in one zone. And then you also have long-time archival of data. So if you want to throw something out there that you say, I'm probably not ever going to need this, but I want to put it out there. And if I do need it, then I'll pay a little bit more to get it back. But I essentially just want to put some data out there, like financial files that I hope I never ever need, but maybe I will. You can get down to less than half a penny per gigabyte for that type of data. So again, I'm not here to teach you about this, but I'm just wanting you to see the pricing examples. But the reason I want you to think about the pricing, let's say on-prem, I'm going to store some data. Well, to store that data, I have to go purchase a disk. And it's not like I can say I'm just going to purchase a disk for what I need. I have to purchase a huge disk so that I can use it. But when we move into the cloud, we only pay for what we use. So now we don't have to pay for the disk. We just pay for the data that we're putting out there. So again, that's object level storage, lots and lots of use cases for object storage. Anywhere from storing documents to storing music to storing the HTML of a website so that you can put it out there, give it an address, and you can easily keep track of a website, a simple type of website out there in object level storage. The next one we have is block level storage. These have sectors on the hard drive, so when you back them up, you only back up the blocks that changed. You can purchase these in solid state drive or hard disk drive. They're just different pricings. And again, block level storage is for usually you run like your databases and stuff, and the things that you back up, you keep it out there in block level. This way, you only have to keep track of whatever changed. Next thing we have is file storage. So multiple endpoints can write to the same destination at the same time. So think of something like a Google Drive when you're thinking of file. I can store a file out there. You can have access to that store. I can map it to my hard drive and make it look like it's a part of my hard drive, but it's really not. It's somewhere else. And we can all map it, so we all have access to that drive. So that's file level storage. All right, the next one was network. So how do we stop bad traffic, allow good traffic in and out on each device? So this is when we're thinking about our financing of this, we think about what are the pieces that we're putting out there. In our old data centers, there might be some physical devices that we put out there, but in our cloud environment, we're not putting physical devices out there, we're putting soft devices out there. And we're utilizing a lot of services within the CSPs to do the same thing that we used to have to purchase hardware to do. All right, and then we're going to look at compute. So many use cases for what we would want to use compute for. But remember, we're in our financial conversation here. So there's different levels of compute. We wouldn't ever want to just go with the biggest, most powerful server. Might be tempted to, because we know for sure that we will have all the power we need. But we're always trying to, we're fighting with our performance versus what we actually want to pay for the services. So something that we really have to be careful about. So again, many different use cases here for compute. They come in different classes. General, and that's good for general day-to-day operations. CPU optimized, CPU intensive workloads like video processing. Memory optimized, really intensive workloads like really large databases. GPU accelerated for things like AI and machine learning, different things we want to do there. And then storage optimized, storage intensive workloads like databases, data warehouses, and such. All right, and the next thing we want to talk about here when we're talking about our financial planning of cloud resources, we think about our chargeback. That's a spin up, shut down, only pay for what you use. So what this is saying is, if I can put in a good start stop schedule, I only pay for the server as it's running up, and then chargeback. That comes into play where we're thinking about, okay, we have different organizations within our company that are using these. How do we charge each of those organizations for the amount of compute that they use? So we're just scratching the surface here. Lots and lots of heavy conversations you can have around that. But one of the ways that we can do this is resource tagging. So whenever you create a resource, you can tag it, and you can give a tag. It can be anywhere from something like environment to where the value would be development, test, production. You could also tag something with an application. So if you have 10 applications running in one group, you can tag those resources. And then that way, whenever you're doing the chargeback, you can go pull back your reports and run them by tag. Now, the key to this conversation, and a conversation I have again and again and again, with resources that I work with, is you have to have a really good strategy, and everybody has to be aware of the strategy, and everybody has to follow the strategy. So, whenever I have customers that come to me and they say, hey, I was just talking to Amazon, or I was just talking to Azure, and they said that we can do all of our billing using resource tagging. I, as the consultant, say we absolutely can, but if it's wrong, you have to have a way to charge everybody. So the best thing to do is say, I'm going to charge the account with what the account needs to pay for. Then we can run reports in the back end to charge out and charge back all of the different groups that you're trying to get to pay you back. And I've had some conversations that got a little heated in this area, because I explained to them, it's your tagging strategy is only as good as the people that are using it. So if people get lazy, somebody has to still pay the bill. So just a little conversation and something to consider. The CSPs will try to tell you that it's perfect, but every one of them have documentation that says everybody has to know what the tagging strategy is, and everybody has to follow it. A little bit on maintenance. So on-prem, 10 to 25% of the base upfront technology. On-prem technology eventually has to be disposed of. With cloud, you just shut it down and delete it. So think about this. When you purchase a server and you put it in your data center and you run it, if the memory chip goes bad 5 or 6 years down the road, which does happen, you have to figure it out and you have to go fix it. Well, when you move to the cloud, that's no longer an issue, because where your application is running today, it may not be running tomorrow. It probably won't be running there tomorrow. You're always running on good, fresh, new equipment. You're never using old, bad equipment or memory sticks that go bad. In the days of this outage was either a hardware or a change, those conversations are much simpler now. It's almost never, ever hardware. If it is, move it. Go try something different. Most of the time, if you have some kind of issue, some kind of outage, it's going to be somebody changed something. So it's change. So a couple of more conversations here on different things that we can do. And this is, when you're talking finances, you kind of get a hodgepodge. You throw everything into this. So if you feel like we're kind of across the board in this one section, we kind of are, but we're still talking about finances. So you have to consider that conversation. So a couple of different ways that we can pay for our hardware. Pay as you go. This means you go into the CSP, you create a server, you use it, and you pay for it as you use it. So it's still very, very valuable to be able to do that. Probably cheaper than you can get it anywhere else, because you're spinning up smaller servers. You're only using what you need. When you don't need it, you shut it back down. But then we get into something that's called reserved instances. So with a reservation or a reserved instance, you're going to make a 1 year or 3 year commitment. You're going to pay all up front, partial up front, or no up front. So with a reservation, it's you're making this commitment. Now, for like government, it's really hard for government resources to make a 3 year commitment. But if you're looking at it and you're saying, I know for sure I'm going to run this server for 3 years, I know for sure I'm going to be in business, you can pay for that and get like nearly a 75% discount by making that decision. So you can make the 1 year or 3 year, and then I don't think they're going to get too advanced in the questions that they ask on this. But some of the questions that might come up around this are, what is the cheapest way to spend money? Or what is the cheapest way to deploy a server? Well, the cheapest way in a reserved instance is a 3 year commitment and pay all up front. Now, it may not be handy to write that check out 1 month, and that's what you have to consider, but that is still the cheapest way to do it. And then the next would be, a 3 year partial up front, then a 3 year no up front, and then it would go to a 1 year all up front, 1 year partial up front, 1 year no up front. You can save more with a bigger commitment that you're willing to make. And then the last one that we want to talk about here are spot instances. So spot instances are dirt cheap. They are like 90% off of the instance, but they only run a specialized type of workload. If you have a workload that can spin up and start, and then within a 2 minutes notice shut down, then a spot instance is a really good way to go. So some examples of some spot instance use cases like genome type processing, where you have a bunch of really small jobs that can run, but you don't need them right away. You just need them run sometime. So you can throw a request out there, and whenever the spot instance drops down to a certain level, it'll start running your jobs. But then when somebody needs that instance back, it will stop your jobs, and you only have 2 minutes to stop the processing. And here it's describing what I just said. Available up to 90% discount compared to on-demand prices. You can use spot instances for various stateless, fault-tolerant, or flexible applications, such as big data, containerized workloads, CI/CD, web services, high-performance computing, and other test and development workloads. Again, the big problem there is you got to have something that you don't need right now. And in IT, that's not always an easy thing to figure out. Some more conversations here around our finance, different types of ways you can license software. There's free for use. This means it's free for use means that it's free to you and you can use it to get to know it. And then there would be some other terms on if you wanted to purchase it. Pay per use. This means that you're going to pay whenever you're using the service or the license. And then there's also the bring your own licensing. This means that you've worked to establish a price point with a vendor. And when you move to the cloud, you'd like to keep the pricing and all the conversations that you had about that so you can bring your own license when you move in. License quantity. So licensing is a complex topic and oftentimes vendor specific. For example, you'll need to know that you need a license for every running instance that you have deployed. The key part is running and powered on. It doesn't matter if the instance is not handling production traffic or workload. So different conversations you can have around the licensing. We've covered a lot in this chapter, from aspects of operating in the cloud and introducing DevOps to explaining the financial impact of operating in the cloud. We introduced data management and how to keep your data available and consistent. We introduced the infrastructure of CSPs with a breakdown of zones, regions, and geographic location or geo-redundant locations. Cloud has enabled the concept of immutable infrastructure or disposable resources. This is where cloud resources are treated as commodities, not permanent fixtures. We showed the importance of alerts and logging to keep an eye on your cloud resources. They will allow you to know what's going on and is set up to be self-healing resources. This self-healing is enabled through auto-scaling. Before any organizations decide to take the leap into the cloud, they need to take a closer look at their on-premise resources to perform the right size analysis. And then we introduce DevOps in general and how you can use tools provided by the CSPs and how to provision resources in the cloud and utilize code to define your infrastructure. There is an important concept of imperative versus declarative when defining infrastructure and resources. This all has to do with your infrastructure as code. Then we discuss the CI and CD and how they are central to every DevOps implementation in the cloud or on-premise. There are various forms of testing that any DevOps team will need to perform as part of the CI/CD pipeline. Automation and orchestration are the cornerstones and the glue that makes the CI/CD pipeline work. We talked about how to perform an upgrade on an application using all of the tools we discussed in the chapter, and the CSPs have built better infrastructure and consumption models around APIs and their integrations. For example, everything in the cloud is an API call. And then we discussed the financial side of going to the cloud and how CSPs offer different tiers of their products. Service offerings will usually fall into either one of the three categories: compute, network, or storage. We discussed the importance of resource tagging and how to accurately track expenditures of services in the cloud. There are currently 3 instance types offered by CSPs. On-demand, which is default. That's just when you sign in, you buy a server. That's how you do it. Reserved, and spot. So we discussed the use cases when you want to use one or the other. And finally, we talked about license quantities and license types. All right, the next thing we're going to talk about is our exam essentials. And remember, the exam essentials are kind of like our little flashcards. And, this is a good way for us to get in here and see what things we understand and what we don't. And if we need to do any studying, this is the best place to tell what you would need to study. Know about data availability and the part replication plays. Data availability is the concept of making and keeping data available to users and applications. Replication is the process of storing data in multiple locations to provide other means of data availability if one location is no longer available. There are 2 different types of replication, synchronous and asynchronous. Synchronous replication keeps data synced in real time. Asynchronous replication replicates the data on time determined by an RTO and an RPO. Know what locality means and understand the benefit the cloud offers. So data locality is the impact distance that has on data access to the end user. Data does not flow through the internet instantaneously, and it will take time to deliver content. The distance between the end user and the data is directly related to the time it takes. CSPs have a global presence and can store data in multiple locations around the globe, thus decreasing the distance and time for delivering content. Know the part backups play in restoring data or services. Backing up is the process of copying data to a medium that can be restored in the event that data has lost or compromised. Backup processes in the cloud are similar to other backup processes performed in on-premise virtualized infrastructures. Snapshots are executed and copied to object storage on a schedule that is aligned with the required RTO and RPO. Know the difference between zones and regions. A zone is either a data center or a collection of data centers within a CSP's infrastructure. The CSP's infrastructure within a zone is within a close proximity of each other and high bandwidth and low latency to facilitate synchronous replication. Regions are logical collection of zones within a CSP's infrastructure. Regions are named after the location around the globe, like US East, Canada, US Central, US West. Know what geo-redundancy is and the part it plays in the CDN. So geo-redundancy is the process of replicating data and services between regions. Geo-redundancy has 2 main goals: keep data and services running if a region becomes unavailable, and offering closer locality to the end user. CDN, or Content Delivery Network, is distributed, for example, multiple regions, delivery network of data to facilitate the locality. Know what disposable resources are and the shift in deployment processes. Having disposable resources is the concept of treating infrastructure that supports data access as immutable or unchangeable. If you have a new version of the application or OS, then do not deploy them into the current infrastructure. Deploy new infrastructure with the updates and changes. There are two techniques for deploying infrastructure more quickly: bootstrapping and golden image. Bootstrapping is having the deployment infrastructure included customization installation through a scripting process. Gold image means having the customization and installation be part of the image that is deployed and already present at the moment of deployment. Know the importance of monitoring and visibility. Monitoring and visibility provide insights and notify when events occur in the cloud. Alerts monitor and produce actions based on the properties of the deployed infrastructure. For example, storage, compute, and networking. Logging is the recording of events or actions that occur either in the cloud or on the resource in the cloud. Logging the cloud is already present and needs to be configured. Logging on resources will require additional setup. Know the process and benefit of auto-scaling. Auto-scaling is one of the coolest features and largest benefit of moving resources to the cloud. You can set parameters that will scale both in and out based on resource health and usage. The cloud can be self-healing when events occur that would normally have a negative impact. Know the importance of right sizing in the cloud. The biggest reason for cloud initiatives fail is cost overrun. This is due to organizations performing lift and shift strategies. They move everything to the cloud. The cost model between the cloud and on-premise is in direct conflict and not compatible. Right sizing is the process of performing analysis of on-premise resources and providing the correctly sized resource in the cloud. This is that same conversation we've had again and again about how when we buy stuff for our environment, we buy what we're going to grow into. But when you're in the cloud, you no longer do that. You build what you need and you try to utilize at the best way the resources that you need. And then if you use other cloud features to increase resources only when you need them. Know the DevOps process and mindset. DevOps has changed historical deployment processes. The CLAIMS acronym is a good one to remember to help understand culture, automation, lean, measurement, and sharing. DevOps tries to turn down the silos that exist in most organizations. The process leads to iterative and have a feedback loop. Know the benefits of IAC, or infrastructure as code. IAC makes your infrastructure be defined as code. This allows the use of tools used in the development process for infrastructure. IAC allows for imperative defining of resources instead of declarative. You define what the resources should be, not what the resources are. There are templates available online to have complex infrastructure deployments that can be tailored to your needs. Know what the CI/CD is and how it relates to DevOps. CI/CD is an implementation of the DevOps process. It uses tools from software development to execute 4 steps of application deployment: dev, build, test, and release. Know various testing processes. Sandboxing is the process of testing changes in environment that is close to production but cannot impact production environment. Load testing is the process of testing new code under circumstances that are close to real world, for example, under load. Regression testing is the process of testing changes through a detailed and documented process that won't reintroduce previously discovered error issues. Know the process and tools used for configuration management. Automation is the method of controlling a process in such a way to limit or even remove any human intervention. This removes the human error aspect and also makes the process repeatable. Orchestration is the coordination between multiple automation techniques. Orchestration brings all the pieces and parts of the DevOps process together with logging, monitoring, and auditing of processes, the entire process. Know the importance of API in the cloud. Every action, whether performed as part of an orchestration or viewing logs in a management console, is an API call. This means there's no difference between web tools, CLI tools, or SDKs. They all perform in the same way. Know the difference and examples of costs using storage, network, and compute. So storage costs depend on the type, object, block, or file. Object storage costs are based on transfer and access, including replication. Block storage costs are based on the type of speed and storage. File storage costs are based on transfer and access. All three have costs associated with the amount of storage used. The network costs are based on the amount of data transferred in and out of the CSP's infrastructure. And then finally, compute costs are based on the resources, i.e. the CPU, RAM, and provision. What are chargebacks and tagging? Chargebacks are the process of assigning cost and cloud resources to either individuals or departments that are responsible for the resources. Tagging is used to correctly assign properties to the resource to identify who is responsible for a resource. Know the three types of instances and their differences. So by default, any instance is on demand. This is pay-as-you-go model, and you pay only for the amount of time the instance is on. Reserved instance type is prepay model. You pay for the resources upfront, even if you're not actively using the instances. And then spot instances are instances that are renting reserved instances not currently being used. On demand is the most expensive option. So spot instances there, again, don't forget, those are the ones that you can start them and stop them, and they don't have to be done. So that's why you would use a spot instance. This slide brings up one fact that the book didn't necessarily mention. Spot instances are actually unused reserved instances. So if somebody's out there and they're using a reserved instance, but then they shut it down, somebody else can come in and pay for the spot instance and use that compute for them. Know the different licensing models and the impact they have on cloud licensing. So there's free for use license that have become synonymous with open source or software that can be used freely without having to pay for any licensing fee. Pay for use licenses, which become synonymous with commercial software, are software that you must pay a fee to use. And use of either in the cloud is available, but the pay for use license is impacted. Use commercial software in the cloud is dependent on the software vendor and must be treated individually. All right, if you haven't read the chapter yet, go out and read pages 163 to 214. Then you can come back here and we're going to go through the written lab and the exam questions. Replication. Blank replication keeps data in sync between two or more locations in accordance with the RPO and RTO. Asynchronous. CSP's infrastructure is broken into logical units called blank, which offers high bandwidth and low latency connectivity. Zones. Blank is the process of scripting or writing code that will configure and customize any cloud resource at the point of deployment. This is bootstrapping. Setting up parameters and resources that will grow or shrink with demand is called auto-scaling. Software-defined networking is an example of infrastructure as code. Blank testing is when new application code is tested against past bugs. Regression. Creating a system that is able to perform the same steps in a repeatable, consistent manner is automation. Blank is underlying technology in all management tools for CSPs. The API, or the Application Programming Interface. Blank are the cheapest instance types and can be utilized in the cloud. Spot. Blank is the technique for being able to use your already purchased license in the cloud on a cloud resource. That's your bring your own license, or BYOL. All right. The CIO wants to cut costs of the instances that are running in the cloud. The instances that have the highest cost are all production instances and require to be up 24/7. Which instance type should you look at? Yep, reserved. I already had it up there. Sorry about that. Since the instances are production and required, reserved the most cost effective. On demand is the most expensive option. Spot is the cheapest, but it's not designed for production instances. You have been tasked with creating WordPress site using open source software and making the primary site highly available within a region. Which option of software and locality would fulfill these requirements? It's that first one. Genix and MariaDB installed on a Udemano 18.04, running both US East 1 and US East 2 zones. You are designing the infrastructure for an e-commerce website that plans on supporting apparel for football clubs around the globe. Which technology should you look at that offers the lowest latency and best performance for your shoppers? CDN, that content delivery network. You need to update all Windows servers from Server 2012 R2 to 2016. You decide the best course of action is to do an in-place upgrade and install Server 2016 over the top of 2012 R2. Is this recommended course of action? Why or why not? This is no, because you're not treating the servers as a disposable resource. So remember, that's the best thing about being in the cloud. You don't need to install a software on top of another server. You blow it away and you create the other one first, test it, then you blow the old one away. You have decided to test your application server on 2016 and want to deploy new instances. Which technology will you use to speed up the deployment and make sure all the servers are deployed in a procedural and repeatable fashion? There are two things here: bootstrapping and golden image. Which of the following cloud resources have a total cost associated with any transfer of data out of the CSP's infrastructure? The object storage and network. Which storage offering will have cost associated with the amount of data stored, even if the resource using the storage is powered off? This is going to be those top three: object storage, block storage, and file storage. Storage isn't like a server. When you shut it down and you cease to pay for it, storage is still taking up space, so you have to pay for it. Your legal department wants to start using cloud resources. However, since all of their work will be associated with legal cases, they need an accurate usage and billing breakdown to bill the client. What are you being asked to implement? Chargeback. The development team has added a new search feature that has never been tested before. Which testing process is more important than the others? Load testing. Your manager wants to do a lift and shift migration from on-premise servers to cloud servers. He has determined that the cloud will save money. Which process is the manager forgetting to complete? Right sizing. Remember, that has to be done or you'll end up spending more money. The CFO wants to be notified whenever a monthly estimated cost reaches $2,000. You will set up blank to notify once the threshold is met. Alerts. What has become synonymous with DevOps and referred to as pipeline and used in the real-world organizations? Continuous integration, continuous delivery, CI/CD. Which of the following cloud deployment models offers the best scalable and cost effectiveness? Public. A blue-green deployment is used primarily when doing blank on production infrastructure. upgrades and patching. Which of the following is not a common characteristic of public clouds? Higher cost. Well, that's just doesn't fit there. Your company uses financial transaction database that updates frequently. If a natural disaster occurs, any data backup older than 1 hour would not be useful to the company. To ensure that backups are always more current, what needs to be specified in the disaster recovery plan? It's the RPO. API integration can be used to manage cloud resources. Which of the following methods? Choose all that apply. So those top three: Web, CLI, and SDK. What storage type is used for the operating system boot partition of an instance running in the cloud? Block. What is the process of combining a series of automation steps into repeatable processes that can be audited? Orchestration. Which of the following are examples of free-for-use license types? Linux and Apache.